In this session, we're going to talk about variables. And like we said, a variable is just a characteristic. Okay? A variable will just be a characteristic. You know, it might be a population or an attribute from that population. Okay? It's very important for you to understand. Now, there are different kinds of variables that you need to understand. Okay? In this case, what are we going to talk about? Types of variables. You can have what we call quantitative, variables, or qualitative. Okay, let's talk about quantitative for now. So quantitative, even just the name quantitative, you're talking about the quantity. So these are variables that can be counted. Okay, they can be counted. In that regard, we are saying they can be what? Also be measured. Something that is counted can be measured. Okay, so they describe the characteristics in terms of the numerical value that is expressed in units of a certain measurements. Okay, so the examples that you can give under quantitative, you can talk about the age. Can you measure the age of someone or something? Yes. Can you measure, you know, what we call parity, the number of live births? Okay. Can you measure someone's height? Okay. Can you measure someone's weight? So these are examples of, you know, quantitative. Can you measure someone's income? Okay. Can you measure someone's, you know, body's temperature, someone's temperature? Yes, these you assume certain numbers like that. So these ones are called, you know, quantitative variables. Now you have to understand something again on quantitative variables. Quantitative variables can either be, you know, let me say discrete variables, discrete variables, or continuous. Okay, let's talk about discrete variables. Okay, as part of quantitative variables. So now discrete variables, these will assume specific values in an interval. For example, like you only have 0. Okay, you only have 1, you only have 2, you only have 3. It's just a specific number. Okay, they only assume values that are countable and they have gaps in between them. Okay, maybe it's a range, but you just only want 2. It's a specific value. Okay, so for example, let's talk about continuous just to differentiate the two. So these continuous, they'll assume an infinite number of values. Okay, we're saying an infinite number of values. Now an infinite number of values, it means it will just be like continuous, right? If I say from 0, maybe I say from 0 to, let me say, 28. Now this will assume all the numbers, whether it's a fraction, from as long as it's from 0. We can talk about 0.2, we can talk about 0.399, we can talk about 4. As long as it's from 0 to 28, it will get all the values. Okay, and in this case there are no gaps. Okay, it will include all the fractions, it will include all the decimals. So this one has no gaps or have no gaps. Continuous quantitative variables. Okay, now let's look at the examples of the two just to differentiate them. For discrete values, we can talk about, let me say, if I give an example of maybe the number of sexual partners someone has. Okay, the number of sexual partners. If I ask someone how many sexual partners do they have, they'll either say I don't have any partner, 0, it's just 0, but they can't say something like 1.5. No, that will not make sense. If they also say 3, that will not make 3 will make sense, yes, because it's a discrete value. But if they say something like 1/2, that will not make sense. Okay, So people are not like in let me say fractions. Okay, there's no half a person. Okay, you just say the actual amount. If there are 2, there are 3, that's what we are calling discrete. On the other hand, we're talking about continuous. It's continuous. Is age continuous? Of course. Age, you can have an age of 0, you can have an age of 0.5, you can have an age of half or 1.5 years. Either way, age is a continuous variable. Income, weight, height, you can have a height of 7 meters, you can have a height of 7.5, okay, or 7.8. It assumes all the values. Okay, so that's what we're talking about. That's how you differentiate the two. Now that we've talked about quantitative, let's talk about qualitative now. What are qualitative variables? Okay, now we are talking about quality. Okay, quality. So these are the variables that can be placed into distinct categories according to a certain attribute. Okay, examples that we can give, because we're talking about quality. Probably you'd want to maybe, let me say, maybe the quality of nursing care. Okay, or the quality of a service. Okay, it's very hard for you to put in numbers. It's just the quality, right? It's a service that you're offering. You might also say the gender of someone. Okay, how do you put gender in numbers? Okay, you can just say someone is male or female. The diagnosis. Okay, the religion someone goes to. Okay, things that you can put numbers. Okay, but that's what we're going to refer as qualitative variables. Now these qualitative variables, you can either have dependent or independent. Okay, you can have an independent variable an independent and a dependent. Now an independent variable, even just the name, it just explains itself. So it's a variable presumed to cause an effect in another variable. For it, it's just a standalone. Okay, it's not affected by anything, but it can affect other variables. Okay, so yeah, that's what we can talk about. So this one, it has an effect. It has an effect on another variable. Another variable like that. So now what would be a dependent variable? This is a variable that is presumed to have an effect which is brought about by another. Okay, so it means just for it to be there, it depends on another variable. Okay, that's what we're talking about here. So now the independent variable, this one usually you are going to represent it on the x-axis. Okay, or we say the x exposure. The dependent variable, this one we usually put it on the y, or the outcome in the y axis, like that, or on the y axis. So that's how they'll be different, because for you to have the y value is like the output. Okay, you have to have some x value. So it's the x value that comes first that will give you a certain y value. Okay, so you cannot have a y value without an x value. That's what I'm talking about. So the x being the one that initiates, it will be independent. Without the x, you are not going to have the y. Okay, therefore the y depends on the x for it to exist. That's what we are talking about we're talking about independent variables and dependent variable. Okay, now let's proceed. Let's talk about what we call scales of measurements. Now this is very interesting and you have to pay particular attention. Now, what are scales of measurements? So variables can be also classified by how they are categorized. You know, the category, or let me say how they are categorized, how they are counted, or how they are measured. Okay, so now what I've just said is what we call scales of measurements. How variables can be classified by how they are categorized, by how they are counted, even also how they are measured. Okay, this is what we call scales of measurements. Now there are about four common types of scales of measurements that you need to know. Okay, number one, you have to understand what we call the nominal scale of measurement. You also have to know what we call the ordinal. You have to understand what we call the interval. And you have to understand what we call the ratio. Okay, now what is the nominal scale? The nominal scale, there's a nominal scale, the ordinal scale, the interval scale, the ratio scale. Let's talk about this one by one. Okay, now the nominal scale classifies data into mutually exclusive categories. Now when you're classifying data using the nominal scale, it means there's no order of ranking. So what you need to know is there's no order of ranking. Okay, for example, can you rank marital status? Can you rank gender? Can you rank someone's blood type? So such kind of things. Can you rank someone's religion? Can you rank someone's political party? So such kind of things. There is no order of ranking. If we're talking about marital status, it's either you're married or single. Okay, so the order and the ranking size are not important. Okay, they are not meaningful. Okay, so that's what we're talking about. Gender, is someone male or female? Blood type, you can't rank that. You can't rank male and female. Okay, blood type is either someone is blood group A, B, A, B or O. So such kind of things, you cannot rank the data. It's just the way it is. So there is no meaningful it's not important to rank this data. Okay, then ordinal data or an ordinal scale. In an ordinal scale, we're talking about data. You're classifying data into categories that can be ordered. Okay, here there is ranking. You can put this data in order. Okay, now in as much as you can put this data in order, there are some exceptions. Okay, for example, there's no precise difference between groups, or precise differences between groups do not exist. Okay, so differences or precise differences between groups does not exist. Now, what are we talking about? Ordinal measurements will just tell you the direction of the difference, okay, between the individuals. For example, let's say educational levels, okay. Some of the examples that you can give here is, let's say educational level. Okay, we can talk about exam grades. So someone's socio-economic status, satisfaction level. So if we talk about satisfaction level, okay, someone can either be satisfied or not, or barely, all those ranges, okay. So you're able to categorize like from high to low, or like that, okay. Then educational level, you can start like from primary, secondary, tertiary. You are able to rank the data, but the thing is that there is no precise difference between grades. You cannot say primary is the things that you are going to do in secondary are less than the one that you are going to do probably in primary. Probably in primary you might even do more, okay. So there's no precise difference between the two. You're just ordering them the way they are, okay. Then a combination of ordinal and nominal, when you combine these two, these ones are called the categorical data. Okay, categorical data. So categorical data, although there are different forms, is what you can categorize the data into two categories. Like this one is called, when you classify your data into two categories, it will be called binary, okay. Now binary to mean is dichotomous, okay. So binary you can categorize maybe someone in terms of maybe being alive and dead. So you can say it's either dead or alive, or someone passed or failed, okay. Or you can say preterm or full term, okay, in terms of the medical language. You can say male or female. So you're just trying to categorize the data. So that's what the nominal scale and the ordinal scale will give you, okay. So that would be binary data. It can also be polychotomous, okay. Polychotomous. Now polychotomous would mean like three or more, okay, three or more categories. Like educational level, you can put it in categories like from primary, secondary, tertiary, okay. Even more categories. Blood groups, you can say A, group B, group AB, even group O, right? You can have more groups, okay. So such kind of things. The race that someone belongs to, are they Mongoloids, are they Caucasides, are they Negroids, okay, or all those kind of races, okay. Are they black, are they white, if there's brown, all those colors, pink if there's pink. So all those kind of things. That's what we're talking about here. Now let's talk about the interval scale. On the interval scale, what are you supposed to know? So when I'm talking about the interval scale, so even the name itself, so this one will rank data. It will rank data. There are precise differences, okay. There are precise differences between the units of measurements or what you are using. However, here there is what we call, there is no meaning for zero. So there is no meaning for zero. Now what do we mean? An example that you can give here is someone's IQ even just the temperature itself. Okay, so you cannot say the temperature of 0 is less than the temperature that is maybe 25. Okay, 0 in this case doesn't mean something. Okay, because if you say 0 temperature, actually 0 might even be more in some areas. 0 might even be maybe more hotter than a temperature range within a certain range. Okay, so the distance between each interval in the scale, they'll be equivalent along the scale from low level to high level. Okay, so like the difference between 10 and 20 degrees is the same between 20 and 30 degrees. Okay, so that's what we're talking about. So there's no meaningful 0. Okay, that's what you need to understand on this one. Then the scale, the ratio, is like now combines everything. Okay, so when we'll be talking about the ratio, it will possess all the characteristics of the interval measurements. And here what will just now be different is that a true 0 exists. Okay, a true 0 exists. It will have everything for the interval scale, but in here the only difference is that a true 0 will exist. Okay, maybe examples that you can give is age, someone's age. You can have an age of 0, you can have a height of 0, the weight, you can have an area of 0. So you need to understand that. Very, very important. So for the ratio scale, it's like it just talks about almost everything. Okay, everything, it includes everything. So now the interval scale and the ratio scale, these ones, they are called numerical measurement scale. So these ones are numerical. Okay, they are numerical measurements of scale. So it's very important to understand that. These ones we said they are categorical, nominal and ordinal. Interval and ratio, they are called numerical because you are talking about numbers. Okay, very, very important. Okay, now let's solve some exam questions. They're saying the 4 levels of measurements. Now, how are we going to categorize them in terms of what we're just from talking about? So if we ask like categories and the labels, categorizes and labels variables. Okay, which one categorizes and labels variables? Do we have categories in nominal scale? Yes. Okay, you're putting the data in categories. Okay, the nominal one. Ordinal, do we have categories and do you have variables? Yes. In interval, do you have categories and do you have variables? Yes. Ratio, yes. So you'll be able to realize that in all of them you are categorizing data. Okay, you are categorizing data, but however, can you rank this data? Okay, nominal scale and the nominal scale, can you rank the data? Like we said, someone's in the nominal scale, like we said, in terms of marital status, someone can either be single or married, but can you rank that? Someone's gender, can you rank someone's gender? Okay, you can't do that because it's just male or female, so we don't have that. Then in the ordinal, do we rank data? Yes. For example, educational level, you can rank, is it from tertiary to from primary to secondary to tertiary? You can rank that. Okay, very important. Then for interval, okay, yes, because the intervals you can rank them from 1 to 2, from maybe 2 to from 3 to 4, from 5 to 6. You can rank them. Okay, they are intervals. Then the ratio, okay, you can also rank them. Okay, like that. Then the other one is has non-equal interval. Do you have intervals in nominal? No. Do you have intervals in ordinal? No, because in ordinal we said there's no there's no precise difference. Okay. There's no precise difference between the variables. Okay. Then in interval, can you put even just the name? There's equal interval, so it's an there'll be intervals. Okay. The ratio, yes. Then has a true or meaningful zero. So the nominal doesn't have, an ordinal doesn't have, an interval doesn't have. Only the ratio will have a true meaningful zero. Like age, you can have an age of 0. Okay, such kind of things. So it's very important that you understand those ones. Now let's talk about the other questions. So we have a question with us. What level of measurements would be used to measure each variable? What level of measurements would be used to measure each variable? A is the age of patients in an intensive care unit. What level of measurements would be used to measure each variable? The age. What measure are you going to use? The age, we said you can have an age of 0. So this would be what? Okay, this would be what? The age. We know that age is a numerical value, so we can have a true value of 0. We can have 0 as odd, right? So we said this is a ratio. You're going to use the ratio scale. Then B is saying the level of cervix dilatation during labor. Okay, what is it going to be? So even this one, you can have a dilatation of 0. So this will be a ratio scale. You're going to use a ratio scale. Then number 3, we are talking about diagnosis for patients in neonatal ICU. So we're talking about diagnosis. Okay, now you can categorize diagnosis, okay, but there's no order that you're going to put that. Okay, so you cannot say this is better diagnosis than the other one. Okay, so this would be nominal. Okay, you are going to use the nominal scale. Then temperature for patients with burns in a surgical unit. Now temperature, we say this is just an interval. Okay, because there's no meaningful 0. Okay, so we talked about that. Then the last one, the amount of fluids prescribed in 24 hours. The amount of fluids prescribed in 24 hours. So the amount can be 0, right? So because it can be 0, this will also be a ratio. You're going to use the ratio scale. Okay, so this is how I approach this one. Let's do the last one. We are saying consider the following situations. Situation A study of 300 households in a small southern town revealed that 20% had at least one school-age child present. Situation B, a study of 250 patients admitted to a hospital during the past year revealed that, on average, patients lived 15 miles from the hospital for each situation. Now they're asking for each situation, what is the sample in the study? What is the population? What is the variable of interest? What measurement scale was used? Okay. Now this is a very interesting topic. It's a very interesting question. So let's start with situation A. Let's start with situation A. Okay, I'm failing to write on my board, so let me just use the other one. I'm failing to write on that picture. So let's start with situation A. So we're trying to find the sample. Which one was the sample? Which one was the population? Which one was the variable of interest? Then what other thing are they asking for? They're also trying to, okay, the measurement of scale. So the measurement scale. Okay, so let's just pass through the question again. So the question is, for situation A study of, oh, actually my borders is back now. So what happened now? Let me just rub here. Okay, so we're saying let's start with situation A. Okay, so a study of 300 households in a small town. So we're talking about 300 households in a small town revealed that 20% had at least one school-age child present. Okay, so from that information, what is the sample in the study? So you're going to realize that the sample in the study is just 300 households in the small southern town. Okay, so 300 households in a small southern town, that will be our sample. Okay, then what is the population? The population is what? All households in the small southern town. In the small southern town, like that. Okay, so then what is the variable of interest? What characteristics are you looking at? So the variable in this case, you're trying to find the presence of at least one school age girl, or let me say age child. Yes, the at least. So the presence, at least you are trying to find the presence of at least one school age girl present, or child present actually. Then what measurement scale was used? That's for now what can you use here? Because you're trying to find the school age, the at least one school age girl child. Okay, so the questions that you're going to be asking, do we have at least one age, just from that you're going to get the question, is there a presence of at least one school age girl or child? So the answer that you are going to be getting is yes or no, or you're going to say there's presence or absence. So because you're trying to find whether it's yes or no, whether it's presence or no, this will be nominal. Okay, so it will be categorical. You're just going to be categorizing. There's nothing like yes or no. Yes is better than no, nothing like that. So it will be like that. So in this case it will be nominal. Now let's talk about situation B. So that's how you go about situation A. Now what about situation B? So for situation B, we are saying a study of 250 patients admitted to a hospital during the past year revealed that on average patients lived 15 miles from the hospital for each situation. Now what would be our sample in this case? We're just talking about the total 250 patients admitted, 250 patients admitted to the hospital during that past year. So that would be our answer. So the 250 patients admitted to hospital during that past year. So that would be your sample. Okay, then the population, what would be the population? The population will just be all the patients admitted to the hospital, or to that hospital. Okay, Then what is the variable of interest? What do you want to find out in here? Patient admitted, patients lived 15 miles. They are saying patients lived 15 miles from the hospital for each situation. Okay, oh, patient lived 15 miles from Easter. So what are you trying to find as the variable? You are trying to the distance lived from the hospital. So you're just trying to find the distance lived from the hospital. Okay, from the hospital, like that. Then what measurement scale was used? Now distance, you can have a distance of 0, right? Although distance might not be 0, but in this case you have to walk some distance, but yes, you can have a distance of 0. The fact that the distance has a 0, whether it's in miles, this would be area. You're going to use a ratio scale. Okay, so this is where we end from for today. Don't forget to subscribe.